All right, today class, it's polynomials and rational inequalities. So we're going to have greater than and less than signs in here. I am sorry the last few videos have been so long. I'm hoping to get this one a little bit shorter and maybe not take so long to get through it. At least you've had a couple of work days on the other ones to get through, and I hope you're using them wisely. Okay, we're going to solve inequalities, rational inequalities, and then we're going to do a few story problems with them. So here we go. Solve and grasp the solution set. Okay, in order to do this and write an interval notation, I almost forgot, you have to set this equal to 0, and we pretend it's an equal sign first. So you set it to equal to 0, and then factors of negative 20 that give you negative 1, of course, are x minus 5 and x plus 4. So this means x equals 5 or x equals negative 4. Write that positive sign better. Now, when you're doing this, these are actual critical points on the graph that we need to figure out what they are. They don't actually equal this. So we draw a number line and we put negative 4 and 5 on it. Now to tell where my graph actually is with this greater than symbol, we take and we plug in numbers in each section into the original, see if it's true or false. So I'm going to pick negative 5, 0, and 6. It looks like some good numbers to plug in. So we plug negative 5 into our original equation. So we're going to take negative 5 squared minus 5 minus a negative 5. Is that greater than 20? The answer is negative 5 is 25. Plus 5 is 30 greater than 20. And yes, so this is a check. This one works. Now we're going to plug in 0. Well, 0 minus 0, is that greater than 20? The answer is absolutely not. So this guy's section is bad. Now let's plug in 6. So we're going to get 36 minus 6. Is that greater than 20? And again, it's 30 greater than 20. So this is a true statement. So this section is good. All right, this symbol here, which is greater than only, tells me that I cannot have an equal sign. So remember, that's our parentheses. So it's a parenthesis at the negative 4 and the 5. So when we write this, it's going from negative infinity to negative 4. So we go like this. Negative infinity to negative 4, union with 5 to positive infinity. And that's your answer. Okay, when we go to graph this, this would actually be a parabola. It would be facing up. It would be dashed. And then since it's on the outside of the parabola, it's going to get shaded. That's where we're headed. We're not there yet. I just want you to get the hang of this. All right, I did everything without that number line. Okay, now it is your turn. So pause and give it a shot. So you should have taken and subtracted the 9, set it equal to 0. You should have said that's x plus 9, x minus 1. So x equals negative 9 and x equal 1 are my critical points. So on your number line, you had negative 9 and 1. You plug in a number on each side, like negative 10, I'd pick 0 again, and 2. So when I plug in negative 10 to my original, I want to know if 100 minus 80 is greater than 9, and the answer is 20 is greater than 9, check. Is 20, I'm sorry, that is a false statement. Is 20 less than 9? I was going too fast, and the answer is absolutely not, so that's bad. Let's plug in 0. Is 0 plus 0 less than 9? Yes, check. Now let's plug in 2. Is 4 plus 16 less than 9? And the answer is no, false. So my true answers are between negative 9 and 1. Again, it's a less than with no equal sign, so it's parentheses. So our answer in interval notation is negative 9 to 1. Parentheses on both sides because we do not have an equal sign to make it a bracket. And that would be your answer. There'd be no union on this one since there's only one section of the graph that worked. Okay, rational are awfully close to the same thing, except now your points of intersection can come from all over. And the first one is when you set the denominator equal to 0. So we set that, this should have said denominator equal to 0. So now we got x plus 1 equals 0. So x cannot be equal to negative 1 because this is where it's undefined. Okay, now we look at this and say, hey, can I reduce this? 2x over x plus 1. And, oh, actually we solved this. So we got 2x over x plus 1. Is this greater than or equal to 1? And we need to solve this and put it over 1. My common denominator is just x plus 1. So now the denominator goes away. 2x greater than or equal to x plus 1. Subtract my x. X is greater than or equal to 1. So my other point of interest is 1. We can ignore this step. So now I've got -1 and 1 on my number line. I need to check areas in each solution set. So I'm going to pick -2, 0, and 2. And we plug them back into the original equation. And the original equation is, let's write it over here so we can see it. 2x over x plus 1, is this greater than or equal to 1? So let's plug in -2. 2 times -2 is -4 over -1, which is 4. Is that greater than or equal to 1? The answer is yes, so this guy checks. Now let's plug in our 0. We're going to have 0 in the numerator over 1 in the denominator. Is that greater than 1? 0 is not greater than 1. That is false. Let's check the next one. 2 times 2 is 4. Over 2 plus 1 is 3. Is this greater than or equal to 1? The answer is yes, so this checks. Now you must also be careful with your parentheses. What you set the denominator equal to 0 cannot equal 1, right? Because that makes it undefined. So this is a parenthesis at -1. So a negative infinity to -1 is how you're going to write this. So in your interval notation, you're starting at negative infinity and going to -1. Now we're going to union. It can equal 1 this time because we have a greater than or equal to when we solved. So it's a bracket 1, 2, positive infinity, parenthesis. I think these are fun. I hope you're enjoying them. Okay, pause and try yours. First step, set the denominator equal to 0. So we know x cannot be equal to 3. So on 3, that is my first point of interest. Sorry. Now we're going to multiply. I got to get a common denominator, which is x minus 3. So this cancels. So 1 is less than x minus 3. Add the 3 over. 4 is less than x. So 4 is my other point of interest. Okay, so now we're going to plug in. Let's pick some points here. How about 0? That's just nice and easy. 3.5 and 5. So if we plug in 0, I have 1 over -3. Is that less than 1? The answer is yes. So this one checks. Let's plug in 3.5. So we put 1 over 3.5 minus 3, which is 1 over 0.5, which is 2. Is 2 less than 1? The answer is no. Does not check. Let's plug in 5. 1 over 5 minus 3. It's 1/2. Is that less than 1? Yes, this checks. Now, which one was not equal to is the 3, so this is the parenthesis. So we're going to go from negative infinity to 3 and 5 to positive infinity. Interval notation, negative infinity to 3 with a parenthesis because it cannot equal 3. Union when? Again, another parenthesis because we did not have an equal sign. So 5 to infinity. I hope you did a great job. All right, let's get some story problems done here. Through here. And again, they gave you the equation, so they were awfully nice to you. Let's see what this does. Okay, an object propelled straight up from the ground level with initial velocity of 80 feet per second. So I know I have 80 feet per second is my initial velocity, which is VO. Okay, its height at a time t, so I know t is time, is modeled by, so they're giving me this formula. So we know ST is equal to -16 t squared plus 80t. For the height, ST, so I know height is the S of t, measured in feet, and the time t is measured in seconds. In which interval will the subject be more than 64 feet? So they're giving me height, and I know height is ST. So 64 is equal to a negative 16t squared plus 80t, but it said more than, so it's just not equal to, it has to be greater than. So I need this to be greater than 64. I need this to be greater than this. Okay, now let's solve this thing. So when I look at it, I have no denominator. So the first thing I'm going to do is set it equal to 0. Let's bring the 16t squared over. We got 16t squared minus 80t plus 64. And I'm looking at this, I'm like, okay, we got to factor something out because that's awfully large. So let's get rid of a 16 because I think 16 goes into all of them. T squared minus 5t plus 4. So that's going to factor into t minus 4, t minus 1. So at t equals 4 and t equals 1 are my seconds. So on my graph, I have 1 and 4. Now we got to check points again. So let's do 0. How about 2 and 5? Whatever you picked. Okay, so if I plug in 0 here, is this true or false? Is 0 greater than 64? The answer is no. That's bad. Let's plug in 2. So now I'm doing 64. And we're going to do a negative 16 times 2 squared is 4 plus 80 times 2. Plug that into your calculator and you should get something greater than 64 because this is 160. This is large. So this is true. Let's plug in 5. So now a 64 less than negative 16 times 5. Oops. Plus 80 times 5. Plug this in. And 64 is less than this is false again. So now it is between 1 and 4 that this is true. Whoa. That was, okay, I don't know why that's still writing. And it's skipping. Okay, good thing it's your turn. Okay, pause and go. Okay, I hope you did well. So you should have got the initial velocity is 48. From the reading, your initial height was 160. You're above the roof, so here's your place, and you're throwing this direction. So you plugged in your 48, your 160, factored out the negative 16. Factors of the negative 10 that gave you negative 3 were negative 5 and 2, which means 5 and negative 2 are your points of interest. So you put the negative 2 and the 5 on. You checked negative 3 or something like that, 0 and 6. You should have found this part was bad, this part was bad, and this part checked. So your interval is a negative 2 to 5. The weird part is, why is there negative 2 seconds? Did you actually figure that out? I hope you realize right here there's no velocity. So the velocity doesn't happen until you're up here is what's going on. So the negative 2 seconds is really back here. Oh well, I hope you did well. That should have helped you a little bit with your physics. Okay, good luck on your homework and do a great job.